constant, but it is a coefficient. A, tadi I guna apa? A lepas tu nombor 2 and then another one X kan. Okay. All these three, we call it as coefficient. So coefficient can be constant coefficient ataupun variable coefficient. Boleh tak? Dapat bayangkan? Sekejap, saya nak menulis ni. Sekejap Saya clearkan dulu. Clear tak? Ataupun nak kena saya explain semula?
Clear, madam.
Okay. Okay, kelas. Now kita masuk on Allah. Hilanglah. Okay, kita dah okay. For this non-homogeneous, the steps it steps quite long. Okay, so you kena do more exercises later. Okay. So kalau for those who have module, please refer to page 38 38. Okay, saya sedang start record. Okay. Okay, now class. Nampak? Tak keluar lagi Nampak tak?
Nampak, madam.
Nampak, madam.
Okay.
Nampak.
Right. Okay. Now, we go for non-homogeneous linear differential equation with constant coefficients. Okay. So in this method, for non-homogeneous, we have two techniques or two methods, to solve, which the first one, method of undetermined coefficient, and second method is variation of parameter. Okay. So linear, about the linear we already learned previously about the degree, and then differential when fx equal to non-zero, still has coefficient. So for method undetermined coefficient, here the method, how can this method solve for your second order non-homogeneous? Is by identifying unknown variables introduced from the assumption of fx, meaning that you have an fx and then you need to assume what is your value of your fx based on the given table. Table will be given because it has standard table. This is the table 2.1 that will be used for you to make assumption for your fx. This is example of your fx. Look at your question. Okay. And then what you need to do, look at this column. After that, you need to make assumption for your fx based on what your equation. You look at this column. After that, you need to go for yp. Yp is something that you create your assumption for your fx. Okay, in form of coefficient. However, here constant coefficient C, D, E. Okay, if for example here maybe can be E, F, G based on your question. Okay, so there are a few steps. Actually, general steps. It has 4 general steps, but inside step 2 you have 4 steps. So totally about 8 steps. Okay, so I share here summary for these steps. Okay, about second order non-homogeneous linear differential equation with constant coefficient. Okay. So we have our non-homogeneous a y double prime x plus b y prime x plus c y x equal to fx, which fx not equal to 0 because non-homogeneous. Okay, I'd like to highlight here. So, 2 methods to solve. The first one, by using undetermined coefficient, and then the second one using variation of parameter. Variation of parameters sometimes being called as variation parameter. Okay. So now we want to focus on undetermined coefficient. So for this undetermined coefficient, okay, steps. Okay, the first one, you need to find your YC for homogeneous. This might be confusing. Might be confusing because this method, undetermined coefficient, is the method that is being used for non-homogeneous. But why we need to go for homogeneous? So this is only steps. Okay, meaning that whatever equation given, the question in the question fx not equal to 0, but for the first step you need to change your fx become 0. That is meant by this for homogeneous. Okay. So yp, second one yp. How to get your yp? So you need to assume your yp based on fx. This one you need to refer table 2.1. Okay, and then yp is, you need to compare whether yp equal to yc pattern or not. Okay. For example, if yes, what you need to do? So you need to multiply yp with x. And then after that, you compare again and again until you find the pattern between yp and yc no more similar, so that you need to stop. Okay, so if yes, multiply yp with yx until the pattern yp not same with yc. And then if you check no, the pattern not similar, not same, so that you just stop. Okay. And then the third step, you need, since previously you have yc and yp, then the next step you need to find yp prime and also yc, yp double prime. Number 4, you need to substitute yp, yp prime, and yp double prime into ay double prime plus by prime x plus cy x equal to fx. Okay, and then obtain c d by equating coefficient. So number 3, general solution, meaning that you need to find y equal to yc plus yp before apply initial condition. So here class, okay, here, so yp here you replace with yp double prime here is yp prime, and then here become yp. I hope this summary, okay, makes you very clear, even if quite simple compared to sentences in the module. I hope this, when you refer this, it will help you when you go for exercises, for example after this. Okay, dah silent ke? Ke tunggu nota saya? Okay, class. Now, before that, I would like to save this first. Okay. So here, CD here, C and D, obtain C and D here, meaning that, okay, obtain value for constant C and D, you need to refer to this table, table 2.1. This is your C, D, okay, E, for example. So these are constant coefficient that you need to find using equating coefficient. Okay. So in this ODE, okay, what you have learned in previous chapter, in chapter 1, so you will use it in the following chapter. So example 2.4, find general solution for 2y double prime plus ty prime plus y equal to -3 exponential x. Okay. So the first step, if you look at the first step, you need to find YC. YC stands for complementary function. C is complementary. Okay. For the corresponding here, okay, here is the word of homogeneous equation. The equation given, okay, based on this equation, what is your fx? What is your value of fx?
-3 exponent -x.
Okay. -3 exponential -x is your fx. We know that this fx not equal to 0 because this is in the case of non-homogeneous. Okay, but for the first step to solve non-homogeneous under undetermined coefficient, okay, under undetermined coefficient technique, the first step to solve this, okay, non-homogeneous, you need to find YC for. YC is complementary function for for homogeneous equation. So what you need to do is to y prime plus 3 to y double prime plus 3y prime plus y equal to 0. Change your fx equal to 0 directly for the first step. So once you change it to 0, you can find the root. you can find the root. So 2y double prime plus 3y prime plus y equal to 0. So you use your calculator and then you will get your m equal to negative half and negative 1. Right? So yx equal to a exponential negative half plus b exponential negative x, half x and negative half x and negative x exponential. So this case is case number 1, right? Case number 1. Okay. So your yx become your become yc, complementary. Okay. Yc. And then you need to find particular integral yp. Yc is complementary, yp is particular integral. So here assume the first thing that you need to look at is your fx and then compare to refer to table 2.1. So your fx, we know that negative 3 exponential negative x. Okay, and from table 2.1, assumption is, okay, how can we check for your fx? Refer to table 2.1. Your fx just now is fx is negative 3 exponential negative x. Okay, this is your fx. Okay, look at here. Okay, here negative k a constant can be negative 3. After that exponential. Okay, same and then nx. N is an integer. Okay, so n become negative 1 and then x. So your fx can be assumed as c exponential nx. Okay. For example, for kx, okay, the pattern here is so that you cannot assume your fx like kx, so that your yp become cx plus d, because for polynomial here k, you have k, okay, negative 3, but for exponential cannot be represented with any variable. Okay, so not meaning that not tally your fx with this kx. And then okay, you have negative 3 exponential negative x. Okay, maybe the main point you can refer here is exponential. So it has here exponent, type of fx is exponent. And then you have the type of product of polynomial and exponential. Okay. And then you have this part k for product of exponential and trigo. Okay, but once you look at here, okay, px is a function of x, so not valid because we have no function attached with this fx. Okay, and then here about exponential and x, okay, it has trigo, so not valid since we have no trigo on our fx. So the best fx is referred to exponential type of fx, and then your fx can be assumed as what your yp can be assumed as c exponential and x. Okay, so c we don't know. Okay, so we leave it as C, stick with C, and then exponential. Now your n here refer to the power of your exponential. Okay, so the power here is negative 1, right? N is negative 1 and then x. So this become C exponential negative x. Okay, if you have negative 3 exponential negative 2x, so your C becomes C exponential negative 2x. Is it very clear here? Is that clear for you?
Clear, Doctor.
Okay. Right. Okay. So that's why your assumption of YP is C exponential negative x. Here we go for step B. Check the pattern of your YP, same pattern or not with your YC. So your YC is here. Make sure, for example, if you get YC, if you have highlighter, please highlight. Okay, because in mathematics, you will play around with so many numbers so that maybe it will take 5 seconds, 10 seconds for you uh, to find your YC. So if you have highlighter in the test, for example, or final, so highlight the value, the important value here. In this case, YC. So highlight for YC. And then check if YC and YP have similar pattern, same pattern. So you have YP equal to CE exponential x. Okay. And then your YC equal to A exponential negative half x plus B exponential negative x. So here, okay, both of these have same pattern. Okay, because you have exponential x. Okay, exponential. Okay, what is the value here after that x? And then it has A and B. C, E exponential negative x. Okay, so same pattern. So since your YP and YC have same pattern, what you need to do, your YP. Okay, because we already complete for YC step. Now, step number 2, we actually looking for YP. Looking for YP. So, what do you need? What you need to do is YP. You need to multiply with X. Okay, so YP you multiply with X become CX. CX exponential negative X. Okay. CX exponential X. Negative X. So here the pattern YP, not same with your YC because you have X in between here. Okay. So since your YP not same with your YC, about the pattern, not the same value, same pattern. Now the pattern not same anymore. So the final YP is your CX exponential negative X. And then please, if you have highlighter, please highlight this. Okay, so YP CX exponential negative X. Okay, then C, find YP prime and YP double prime. So you have YP, YP from B, and then you need to differentiate YP, apply product rule. Still remember product rule? Macam mana? Dx U V equal to U dV dx plus V du dx. Sometimes you can use U V prime plus V U prime. This is product rule. Okay. So class, for your YP here, which one you can choose for your U? You want to choose X or exponential X?
X.
X. Can we choose exponential X as U? Can or not?
Can, madam.
Can.
Yeah, I think can.
Yes, can, because for this, you only have U V prime and then V U prime. And then it starts with U V. Doesn't matter which one you take for you take as your U or V. Okay. Finally, you will go for both of them. You need to differentiate. And then here is plus. Okay. This is different. Okay. If you use integration of UV. This one you need to go tabular integration. So that one you need to choose carefully. In this case, product rule, you can select your U or V. Okay, tak kisah. So whether X become your U or X become your V. Okay, not a big problem for here. For you to solve here. So if you choose U equal to X, du become 1 du dx. Okay, if we, after that, v equal to exponential negative x, dv dx become exponential negative x, negative 1. Right? Okay. So, and then u v prime plus v u prime. So, u is x v prime exponential negative x plus v. V is exponential negative x du 1. Okay. And then C outside. Okay. So that become like this. Okay. And then double prime, the same technique. Okay. You can choose anyone as your U or V. Okay. And then you will get this. Okay. Cuba buat yang ini. Boleh dapat tak? Double prime. Dapat tak?
dapat.
Then substitute your YP prime and YP double prime into 2y double prime plus 3y prime plus y equal to negative 3 exponential negative x. Okay. So here become your y double prime become your y p double prime. So replace your value here with your yp that you differentiate just now, and that equal to fx original from the equation. Okay. So this is yp double prime here, yp. Okay, by equating coefficient. Equating coefficient here. Okay, you look at on your left hand side. Okay, equating coefficient. Okay. So here equating coefficient, why haven't used x exponential negative x here? Why we not go for x? Okay. Actually, if you go for x, okay, here x, kan? Kalau you go for x exponential x, ke belakang ada sekejap Tak ada. X, if x2 plus negative 3, sorry. For x exponential negative x, so 2c minus 3c plus c kan, is part equal to 0. Boleh dapat tak? So yang ini can be cancel. So become 0. So that's why this is not been written here. Okay. Because in the end you will get both sides 0. Okay. 2, 3, meaning that negative 3c plus 3c kan, so 0. Okay, that's why not valid. And then at the same time here exponential. So for exponential negative x, you have 2 times 2 negative 4c plus here 3c equal to negative 3. So c equal to 3. Boleh?
Macam mana ni?
Macam mana?
Tak
Equating. Equating coefficient.
Ha.
Equating coefficient, you need to look at whatever you have on your left and right hand side kan. So on your left, you tengok function-function yang ada x. Okay. Kalau you move left to right macam gini kan. You tengok ni ada x exponential negative x. So you can go for equating coefficient x exponential negative x. Ataupun otherwise you can use like this. Exponential x pun just fine. Masih boleh. Okay, so your maths ni sebenarnya banyak jalan yang you boleh try ataupun you boleh buat. So become 2cx tolak 4 ni darab ni, kemudian darab dengan ni. 4C. Okay. After that, bacakan saya. Siapa yang bertanya tadi? Tolak.
3CX
Okay, lepas tu
tambah 3C.
lepas tu
Lepas tu tambah C.
tambah C. Awak tengok ni, equating. C ke CX?
CX.
Sama dengan
Dengan 3.
negatif.
Oh, negatif.
Okay. Bila negatif 3 sini, okay, you selesaikan sebelah kiri. Okay, so for on the left hand side, so CX dengan CX kan, 2CX tolak 3CX dapat negatif 1 kan? Negatif 1CX. Negatif 1CX tambah 1CX jadi kosong kan? Betul?
Betul.
Lepas tu yang tinggal negatif 4C tambah 3C sama dengan negatif 3. Betul?
Betul.
So yang ini. So yang ini you selesaikan dapat negatif C sama dengan negatif 3. Betul?
Betul, betul.
Boleh cancel. So C sama dengan 3. Right? Okay. Boleh? Ada soalan lagi? Okay. Next page. So, YPX mana? Okay, so YP equal to, so C kan? Just now YP tadi berapa mana? YP is CX exponential negative X. So since your C equal to 3, so YP become 3X exponential negative X. This is your YP and then please highlight. Okay, use highlighter, highlight this YP. Okay. So 3X exponential negative X. And then find general solution here. General solution, we know that Y equal to YC plus YP. Okay, YC and YP in function of X. Same goes to this Y, function of X. So we have YC. This is YP. Okay. Right. Ada soalan lagi? Okay, example 2.5. You boleh try. However, this is a function that you need to revise back your trigonometry. Your trigo. Okay, you may try. So for those yang who have module, so okay, just fine. Yang tak ada module may try lah. Sebenarnya sometimes if you try and then you get a different answer with mine, and then this will help you to remember and understand more. Because this is maths. Maths not for you to read, but maths is for you to go for more exercises, more and more exercises. Okay. Ni salin, copy this. Okay, this is initial condition given for, make sure initial condition here given in y(x) and also y prime x. Okay. Be careful. Okay. So I give you 5 minutes for you to try this. Have you copied this equation? That's why I want to show you the step. The step you copy dah. And then table kan you need to check from the table. I think better I share the table. Semua buat tak ni? Everyone, have you tried?
Tengah doktor.
So here, what is your assumption of YP? Which one? YX, sorry, YX is 2 sin X. Okay, 2 sin X. So your YP? your fx is 2 sine x. So yp
C cos nx plus D sin nx.
which one? 1, 2, 3, 4, 5, 6. Which one?
The third one, third one.
Third one.
Yeah.
Which one?
The
The bottom
Ah.
one.
the top one.
Okay. This one. K sign. Everyone? Dapat tak? Is everyone got this?
Dapat.
Okay. Dah sampai step mana? Okay. Right, class. So find complementary function YC for the corresponding homogeneous equation. So Y double prime plus Y equal to Fx equal to 2 sine X here. So use your calculator, you will get your your root. So this is case 3. Case 3. So case 3 Y. Masih ingat case 3 ni dapat dari mana? Based on your root, kita ada case yang M1 not equal to M2 and real, both M1, M2 are real. The second one, if you get M1 equal to M2 equal to M, meaning that you get same root value, and then the third case if you get in form of real and imaginary, or we call it conjugate. So conjugate is case number 3. So I see equal to A cos x plus B sin x. Okay. So find particular integral YP. So YP, look at your fx to sin x just now. Okay, your friend share the answer is need to use C cos x plus D sin x. Anyone need more explanation about how to get YP here? I give you 5 seconds to ask. 5, 4, 3, 2, 1. Okay, hopefully you very clear on this. And then step B, if YP has same pattern of with YC, so compare. This is YP and YC. Okay. Do these have same pattern? Same pattern? Same, right? Okay.
Sama Dr.
Yes.
And then what you need to do, this part, since your step 2, we need to find your YP. So YP need to multiply with X. So YP become CX cos X plus DX sin X. Okay, this is your final YP. Please highlight like this. YP and then YC mana? This one. Okay. Okay, find YP prime and YP double prime. Sekejap ya. Find YP using product rule. Dah try dapat ke tak the answer? Sometimes module can have a mistake. So have you tried this? YP prime and YP double prime? Diam sunyi je. Eish. Oh ni. Dah nak raya. Okay, I don't want to go step by step here. I just want to show on step 2. C. So YP prime and YP double prime. Step 2, I'm using number 3. Doesn't matter, not a big deal. So YP, we know YP equal to CX cos X plus DX sin X. So using product rule. Product rule, ddx uv equal to uv prime plus vu prime. Okay, this is product rule. So yp prime so here u equal to x. We go one by one. Okay. First one for cx cos x. Okay. U equal to x. U prime equal to 1. V equal to cos x. V prime equal to V prime. Differentiate cos, you'll get
Negative sine x.
So for this one, you will get U is x dv negative sine x plus V, okay, you have C in front, okay, plus V cos x du is 1. So you get C negative Cx sine x plus C cos x. Okay. And then look at dx sine x. U equal to x, U prime equal to 1, V equal to sine x. So V prime equal to cos x. So this become d U is x dv cos x plus V sin x du. Dx cos x plus d sin x. Okay. So after that, you need to combine both of these. Yp become negative cx sin x plus c cos x plus dx cos x plus d sin x. This is yp prime. Ni baru satu. Yp double prime. Here is y. Allah. Yp. Yp prime. So double prime. Okay, again. U equal to x. U prime equal to 1. V equal to sin x. V prime equal to cos. Okay, so negative C. You need to go one by one, eh? So yang ini quite, you can refer to the module lah. Okay. You want to go faster? Okay. You don't want to write like this. Okay. Just to show you. Okay. This is U. Okay. Look at here, class. U and V. Eh? U, V. You have negative C. Okay. U. U is X. So U, V prime, differentiate sin X become
Cos X.
cos X plus V is sin X, U prime 1. So just close the bracket plus C cos X, differentiate cos become
Negative
negative.
sin X.
Negative sin X. So So negative plus dx cos x, d, okay, u is x, v prime is
Negative sin x.
negative sin x plus
Cos x.
u dv. U is cos x, dv is 1 plus d differentiate sin x become cos x. Okay. Okay. So here you can look at x cos x and then what else? Cos sin you can factorize. So for cos x you have negative cx cos. Look at cos. Cos, okay, plus d, right? Plus d okay, plus sin x cosine x negative c okay, minus c okay, sin negative c negative c negative negative
dx. dx.
x dx.
Adam,
Yes.
yang cos tu tambah 2D rasanya. Yang cos X.
2D
Sebab yang D darab cos X lagi kan?
ni.
Yang
Cos.
sebelum tu terms tu yang D.
Oh, ya. Ini macam plus D, right? Macam gini tertinggal. Betul So nanti you ni step by step kat sini lah. So negative C. Thank you Siapa tadi betulkan saya? Okay. Right. This is YP double prime. Okay. Okay, boleh. After that, substitute lah. So substitute. Saya dah tak tunjuk lah sebab ni aku cakap you boleh refer yang ni. So you will get these three functions, YP, YP prime, YP double prime. Substitute. We use YP double and YP equal to sin x. So this become like this. Okay. And then you need to use equating coefficient. Equating coefficient. So you can, okay, here is sin. Cos boleh juga. Okay. So buat mana-mana lah. So sin and cos. Whatever you have for x ni, you boleh go for equating coefficient. So cos x, sin x. Right? So cos x, you have... Okay. Betul tak ni? Ada tak yang buat? Is there anyone here, okay, for cos x uses x cx, sorry, negative cx, okay, plus 2d, so that plus cx, ada tak equal to 0? Ada tak yang buat begini? Ada tak? Hello everyone, this is tutorial session. So, ada ke yang buat begini?
Dapat lain doktor.
Buat lain?
Madam, saya terus guna 2D equals to kosong. Sebab kan negatif cx tambah cx dia jadi kosong kan. So saya terus ambil 2D equals to 0.
Yes, correct. Kalau you buat begini pun betul. Sebab ni can be cancel. Dapat semula yang 2D equal to 0. Okay, sama je. Apa yang lain tadi, siapa yang dapat lain? Can you please share with your friends here? Maybe you have other friends that use the same method as yours. So, you guna macam mana? Boleh saya tahu tadi? Yang guna dapat lain tu?
Saya dapat lain doktor.
Siapa tu?
Hafiz.
Hafiz, macam mana?
Sebab saya tengok kat sini kan dia cos x. So saya buat 2D tambah cx.
Macam mana? Macam mana?
2D.
Oh, cos x.
Sebab untuk
Okay.
cos x tu saya ambil 2D tambah cx equals to
Okay.
0. Lepas tu
Equal to
saya
0? Okay.
Lepas tu saya substitute C tu, saya dapat order sin x tu masukkan negatif. So saya dapat
Chop. Lajulah.
saya buat sin x dulu. Sin x tu saya dapat C equals to negatif 1. Lepas tu saya substitute dalam equation cx tu. So saya dapat 2D minus x equals to 0. Lepas tu saya dapat x over 2.
Yang ni awak selesaikan tak?
Saya buat sin dulu, dan baru saya buat cos.
Buat sin dulu? Oh, okey lah. Tak apalah. So, kalau buat sin, maknanya awak buat untuk sin 2D tolak x.
Dan saya dapat value sin x ni, saya dapat C equals negatif 1 ni. Dan value...
sabarlah. Saya bukan nampak awak tulis apa. Awak beritahulah. Okey.
Yang macam ni doktor. Saya punya jalan kira sama macam dalam modul ni.
Awak guna dalam modul?
Macam dalam modul ni, saya punya jalan kira. Cumanya, saya buat sin dulu. So, saya dapat value C dia.
Dapatlah yang ni.
Negatif 1 ni saya dapat.
Okey, dapat. Okey. Tak kisahlah, buat sin dulu.
Yang cos ni, yang macam tadi saya cakap tu, saya dapat 2D. Lepas tu, okey doktor, saya tertinggal C depan tu doktor.
Ni?
Okey, saya salah. Saya tertinggal negatif CX depan tu.
Boleh dapat
Okey doktor.
Alright. Okay. Great. Very good. Saya suka betul lah mengajar section 8, section 9 ni. Okay. Most of you boleh macam ada bagi feedback. Okay, try. Whatever given kat sini kan. Okay, very good. Okay, ni belum raya lagi ni. simbol dah tertinggal. Lepas makan kuih raya ni takut macam-macam tertinggal. Make sure kita ada test nanti. Be careful. Right, therefore YP, okay, you akan dapat YP negative X cos X nanti. Find general solution. So Y equal to YC plus YP. Masukkan, this is your YC and then plus YP that you just got just now. Apply initial condition. Okay, apply initial condition here. Okay, initial condition. Okay, you have the first one yx equal to 4 and then the second one y prime x equal to 3. So that for this part, okay, you use y. Okay, mana tadi? Y here. Okay, this one you apply. After dapat y equal to yc plus yp. And then masukkan, okay, substitute your x equal to 0, y equal to 4. Okay, so here yx equal to y sebab dia punya konsep here yx equal to 4 or yx equal to y. Okay, yang inilah. Cakap y tak y juga 4 lah. Yx equal to 4. So that's why 4 a cos x. Cos 0 equal to 1. Sin 0 becomes 0. Cos 0 become to 1. But this is x equal to 0. So this becomes 0. And then a you get 4. And then y prime. So for this you need to differentiate yx. So differentiate this one. Okay. So you need to differentiate a cos x plus b sin x minus x cos x. You need to differentiate this first. Ada tak differentiate dia punya differentiation? So differentiate this. Okay. Sebab tadi just now x equal to tadi modul yx a cos kan? A cos x plus b sin x minus x cos x. So differentiate cos x dapat negative sin x plus b sin x, differentiate sin dapat cos x minus yang ini you use product rule. So product, after use product rule you will get this. Okay. So you apply initial condition. Initial condition given y prime 0 equal to 3. So 3 x0, apply x0 here. So you will get b equal to 4. So particular solution right now is yx equal to, this is a just now, and then a berapa tadi? 4 juga b sin, mana particular solution you? Masukkan balik lah. B. Kenapa B 4? B dapat berapa tadi? 4? B 4. Kenapa saya dapat 2 lah? Sekejap. X 1, 0, 1. B equal to 4. Ada salah mana-mana ke? 4, 4, 4. Dapat tak 4?
Dapat, madam.
Oh, saya silap kat my notes ni. Sign, saya punya sign silap. Okey, dapat. Okey. Okay. And then 10. Oh, okay. So I give you 10 seconds if you want to ask anything. And then next class we can discuss other example.
Madam,
Alright.
untuk table 2.1 tu kalau dalam exam dia ada bagi ke tak?
Bagi, mesti bagi kalau digunakan. Okay, kalau tak ada soalan, class dismiss here and then kita continue. Sebenarnya hari apa hari Selasa tu ada buat latihan sedikit untuk homogeneous tapi tak apalah sebab saya rasa homogeneous tu very simple Okay. Nanti kita sambung lah. Kita akan tengok example 2.6 ni macam mana datangnya E semua ni. Okay. Right, yang ni saya tak ada discuss lagi belum discuss lagi. And this part ni sebenarnya saya discuss daripada modul lama saya ni. Saya conteng-conteng lama. Okay, so class dismiss here. Okay, tak ada apa-apa soalan. So see you on next Thursday lah. Tuesday, hari Selasa pukul 11 pagi. Okay, selamat Hari Raya. Maaf Zahir Batin. Bye.
Terima kasih doktor.
Sama.
Thank you, madam. Selamat Hari Raya, madam.
Okay, selamat Hari Raya.